Warning: chloroform is carcinogenic. This reaction should be performed outside or in a fume. Greetings, fellow nerds. I need some chloroform and propionic acid, and a convenient way to make both is the haloform reaction. In this video, I'll show how to make chloroform, and in an upcoming video, I'll further process the products to make propionic acid. So let's get started. Get about a liter of sodium hypochlorite bleach that's been previously cooled in a freezer. Now this reaction is also quite exothermic, so it helps to build an ice bath around your bleach as well. Looking back, I probably should have used a bigger ice bath, but I want you to see the reaction as it progressed. If you perform this reaction, then try to use an ice bath that covers most of the beaker for best results. Now I'm lowering in a thermometer to monitor the reaction. This is optional, but helps us know if the heating is becoming excessive. Now we start adding inorganic ketone. Most amateurs that do this reaction use acetone, but I'm going to use methyl ethyl ketone, also known as 2-butanone. I'll explain why in a minute. Now the bleach I bought claims to be 8.25% sodium hypochlorite by mass, but I only found about 7% through titration. So I'm going to add a total of 22 grams of methyl ethyl ketone. Now there is an induction period between adding the ketone and when the temperature spike occurs. So don't add it all at once thinking nothing is happening, as reaction will boil out of control when it finally does start up. But don't take too long either, as the chloroform produced decomposes under strongly alkaline conditions. What's happening is a well-known reaction called the haloform reaction. In this reaction, 3 moles of sodium hypochlorite react with 1 mole of the methyl ketone to form a carboxylic acid and chloroform, as well as sodium hydroxide. Now the carboxylic acid is whatever was on the other end of the methyl ketone. So if acetone is used, then we get acetic acid. If methyl ethyl ketone is used, then we get propionic acid. So by using methyl ethyl ketone, we can create 2 useful products with 1 reaction. Now I said before not to go too slowly. This is because chloroform reacts with sodium hydroxide to produce formic acid and sodium chloride, wasting our chloroform. Try to keep the temperature below 30 Celsius and add everything within 30 minutes. Looks like I overshot mine, but it will still work. When the reaction finally finishes, the solution will go colorless as the yellow-green hypochlorite ion is completely consumed. If you are uncertain of the exact concentration of your bleach, you can use the color change as a crude titration endpoint to determine when you should stop adding ketone. At that point, take it off the ice bath and turn off the stirring. Now something I noticed is that if you use too much ketone, then after the reaction goes colorless, it will start to gain color as the ketone decomposes in the presence of the sodium hydroxide. The color change can be extremely misleading as it makes you think there is additional hypochlorite ion. So if you see your reaction go colorless, then stop adding ketone and ignore any further color changes. They're just decomposition products. Now the cloudiness is from tiny little droplets of suspended chloroform, so let the containers sit until they all settle out. This should take a few hours. Now chloroform is denser than water and will form a layer on the bottom. When it's fully settled, decant off most of the upper aqueous later. This will make it easier to handle. You can now clearly see the chloroform layer on the bottom. Now I'm separating off the chloroform by withdrawing it with a pipette. You can also use a separatory funnel. I'm not going to bother since I have such a small amount. And there we have our crude chloroform. I got about 17 grams for a yield of about 45%. Now I did this whole reaction in the speaker to show you the process, but if you need to make large amounts of chloroform, you can actually add the ketone right to the bottle. The only drawback is that you can't see what you're doing. Nonetheless, it's more convenient than finding a huge apparatus like beakers. I'm going to convert the rest of my bleach that way. Now the chloroform contains small amounts of water and unreacted ketones, so you can remove the water by shaking it with a desiccant, like anhydrous sodium sulfate, molecular sieves, or even sodium chloride salt. To remove the ketone and other impurities, you can fractionally distill your chloroform at 61 degrees Celsius. Now over time, chloroform slowly reacts with air and light to produce highly toxic phosgene gas. You can stabilize it by adding some alcohol like methanol or ethanol, around 1% by mass. It's also a good idea to store the chloroform in a dark or opaque bottle. I'm going to use mine very soon, so I won't bother. But if you're going to keep it around for longer than a few months, you should. Now if you have chloroform that you don't want to deal with anymore and you want to get rid of it, then rather than dumping it down the sink, you can destroy it by mixing it with concentrated sodium hydroxide and letting it sit for a few days. As mentioned before, sodium hydroxide reacts with chloroform to create sodium formate, which is benign, and salt. A lot of halogenated compounds can actually be destroyed this way. Now, I said before that the aqueous layer has propionic acid, and I'm going to recover and purify that in an upcoming video. So please subscribe, like, and comment.